and I found out as we were going through our notes and stuff about pacing and scheduling for this unit is this first half of the whole chapter is so much review from everything you've done, and we've kind of realized that as we were going through a lot of our trig stuff, when we were building the unit circle, we did a lot of this already. So just as a reminder about how you find sine when you have the ordered pairs given to you, sine, cosine, tangent, all that kind of stuff. Remember that the sine of an angle, when you're dealing with the unit circle, or if it's placed in space on the coordinate plane, is y over r. Cosine is x over r. Tangent is y over x. And we talked about that when we had the ordered pairs for unit circle. Cosine was your x value, sine was your y value, and so on. And then it's just the reciprocals for the inverses. So your cosecant is r over y, secant r over x, and then cotangent x over y. And when you do these problems, these are the ones that they're going to give you like an ordered pair in one of the quadrants, and they'll ask you to find the other 5 trig functions. So this is a pretty simplistic thing to look at. Let me give you an example. Let's say you have the point -3 and 4 be on the terminal side of theta. That just means that theta comes to point -3, 4. So you have to know where -3, 4 is in space, as what quadrant? What quadrant is that? 2. It's there. And theta comes around like this. That's what that means. That's how that works. Knowing that, that means that your y, when you have your sines and stuff, if this is -3 and 4, here's your x, here's your y. To get the value of r, well, it's x squared plus y squared. You're using quadratic formula. Okay. Yeah, that's a quadratic formula, sure. Pythagorean. Okay. Because what you have here is the start of the right triangle. 3, 4. What's the hypotenuse? 5. Okay. So that gives you the r value of 5. And then it's just a matter of listing out the trig functions. I hope that's not tough. That should make you happy, because that's easy. Whatever, start with sarcasm. Oh no, I don't know what you're asking to do. I haven't done that yet this year, have I? Or have I?
I've been meaning to. I've been waiting for that.
Yeah, absolutely. Yeah, when you're dealing with these are all terminal sides of theta, and to get the value of r is always going to be the square root of x squared plus y squared. If by chance you are using your calculator to square -3, please be smarter than your calculator and put parentheses around it. That's about as crazy as this stuff's going to be. Okay. You'll see a lot of triples with these things. You guys remember those? No.
That's the
There's
same.
115 in it, I think.
Oh, it's 3, 4, and 5. I just bought it. Yeah, I was just showing how this value in oops. That's a family of 3, 4, 5. What I was showing here is how this just creates a right triangle, and so that's why we use Pythagorean. Yes, Pythagorean theorem to get the value of r.
I think we need to be fired.
Oh my god!
Shots fired.
Wow. Jeez.
I missed
No, Mr. Murphy knows that I like him.
And then you think you should get fired.
Right. A lot of teachers are having problems talking today. Like my last teacher couldn't say anything.
No, oh my gosh, he stutters so much.
And he
Same
couldn't
idea.
say
If
things
tangent of theta is -5 and 4, and the cosine value is going to be greater than 0, find sine and secant.
out.
So that means you have to think about what quadrant you're going to wind up being in if cosine is positive, but tangent is negative? Cosine is positive,
Oh,
tangent
it's
is
in
negative.
The first or the third or second or fourth.
It's the fourth.
May the 4th be with you.
Say anything, Madeline.
Cosine is positive, but tangent is negative. It's got to be fourth quadrant. So if that tells you that your tangent value is 5/4, so that means that 5, because remember, it goes which one of those has to be the positive value, the 5 and the 4? If it's going to be in the fourth quadrant with a positive cosine.
4 is the
4 would have to be x. Okay? Because remember, 4 is the x. So if it's at 4, -5, that means the value of cosine, since that's the x value, it's positive. The sine value is what's negative there. Okay? Now, you still got to figure out what r is. So we have to do, that's not 3, very good. So we're going to have to do 4 squared plus 5 squared and take the square root of that. So 16 and 25 is, is it 41?
I think so.
Sure. So the value of r is square root of 41. So sine is y over r. Well, that's -5 over root 41. Means we have to rationalize. And then secant, that won't be so bad. The secant value is going to be the inverse of 4 over root 41, so it'll be root 41 over 4. And I'll double check with Fontana. I think at some point in time we stopped rationalizing denominators. I just don't remember where that happens in pre-calc.
We get to slap them.
I think so. I don't remember when though. I know there's this. I know there is some. There is some point in pre-calc that they sometimes do, but I just don't remember where. Let's try to.
Well,
Trig functions of quadrantal angles. We did this already. What I'm looking at here, what are this? How do you do your trig functions on the quadrantals? 1, 0, 0, 1. It's just a matter. What is your value of r on the quadrantals? Yes, sir.
I know the answer, but the bottom one, should it be 0?
Yes, it should be.
I don't know the answer.
But I know that you're wrong with what you did. What's the value of r when you're on the quadrantal?
1.
1. So this is the case where you're just quite literally taking the values of x and y and substituting them through. So if I want to do my quadrantals here at pi, if I do the 6 trig functions there, cosine is x over r. Well, x and r are the same values. Well,
1.
it would be, actually in this case, it would be -1. Sine would be 0. Tangent would be what? What else would be 0? Y over x would be 0. And then when you do your inverses, what's the inverse of -1? -1. What's the inverse of 0? And the inverse of 0. What's the inverse of undefined?
0.
0. So it goes back and forth like that. Okay? Not 0.
Hilarious.
Thank you. I'll be here all week. Thank you. Yes.
Tomorrow's the other day. You actually weren't here all week because you weren't on Tuesday.
You know.
The rest of the week. What about the weekend?
So I know that you guys have done these. These aren't difficult. Just be careful when you do your inverses when you have zeros. The inverse of undefined is 0, and the inverse of 0 is undefined. Also, don't make the mistake when you flip it. Don't do the opposite reciprocal, like you're thinking of perpendicular slopes. That used to be a big mistake you guys did back in the day. So don't do that. Reference angles. We did this already as well. Remember, what I want you guys to remember about a reference angle, a reference angle is how far you're bounced off the or the x-axis. Your reference angles are always bounced. They're always bouncing from the horizontal. Okay? They always bounce from the x-axis. All right, you knew that. We've done that before. We utilize reference angles to build ourselves back into the special right triangles all the time. So if I say, what's the reference angle of -5 pi over 3? What direction would I have to go? I have to go clockwise. I have to go down first and work my way around. Well, how many times does 3 go into 5? Once, with 2/3 left over. So we count it. 1 little pi. Is 2/3 pi past halfway?
Yes.
I feel like I'm on
So you have a pi over 3 reference angle. We did this back in 4.1 and a little bit of 4.2. I had you guys doing those types of problems by bouncing them around via reference angle, as opposed to what they were doing in the book by just adding, subtracting values of pi. That's just dumb. Do it this way, it's easier, it's quicker, it's the way the regular people do it anyway.
Right.
It's pi over 3 away. If you remember what you're doing, you're spinning it to figure out what quadrant you bounce into, and then you just figure out, well, how far much further do I have to go to complete to get to one of my reference, my x-axis. Right. So that means this angle then for the terminal side of theta, I'd be using pi over 3 to figure out whatever these values are. So it would be at 1/2 and √3 over 2, and that you would everything. So for example then, if I want to find the reference angle of 300 degrees, yes, the book still uses degree symbols, I don't know why, but it does. Where does 300 degrees roll into?
The fourth quadrant.
It rolls into the 4th quadrant. And then how far are you from bouncing back up? So what's your reference angle? 60 degrees or pi over 3. Very good. This one's weird. 2.3. Notice there isn't a degree symbol. That stands for 2.3 radians. Okay. Now, 2.3 radians already has, if you think about what a radian has pi built into it. You agree on that?
Yeah.
So what you do here to figure out value then is think about how you convert back and forth between radians and degrees. Or,
You do 2.3.
yeah. So you have 2.3, that you take out the pi, and that'll tell you rough degree then. So 2.3 divided by pi is going to be something. I forgot.
But don't you have to put it over
Yeah,
times the
something like that. Okay. I forgot what the point was. I'm looking it up. So I forgot. Oh yeah, that's all it is. Duh. So think of it this way. If this is it's already built in with pi. Pi is here. You agree? This is pi over 2. What's pi? Or decimal value? 3.14159.
2.6.
Bloody flipping dot. So it's probably between these two. So how far would 2.3 be from pi? What would you do?
3.14.
Oh, it's dumb.
It is. Using it with just a straight radian value is kind of silly. More often than not, it's going to be within degrees or just straight radians with pi. It's just one of those things. It's just like kind of an approximate of where things are going to get thrown. Should we do the pi contest this year?
Yeah.
The what?
Like a little line.
Yeah.
No,
the
like
fastest.
pi recital. Who can go the most digits?
I think Jenna's gonna win. Yeah. We should have like a third place because maybe I could get third. But
We should do like,
What do we win?
I feel like Mark's gonna
$1
win.
million.
extra credit.
you get
Powerball.
Let's do it.
$1 million. I will make you a $1 million bill that will be legit.
We get 5 points.
Pride.
Yes.
Well, I think first place should get like 15 and then like 10 and then like 5 like.
And back to something like this, evaluating the trig function at a specific reference angle. This is the kind of stuff that we spent so much time in Algebra 2, and then we kind of did a little bit of this in 4.1. What you guys did in 4.1 is just found all 6 trig values at a specific point. Now they're just finding one of them. So if I'm looking to find the cosine of 4 pi over 3, we got to place it on the unit circle and figure out where it goes. 4 pi over 3, is that more than a pi or less than a pi? More than a pi. So if I spin it, it's going to come past pi and go down, what, another third? So it gives me a pi over 3 reference angle. Which is what, which angle? Very good. So I know that I have a 60-degree angle. So that's the, oops. So it's 1, root 3, and 2. And I'm in the third quadrant. Will cosine be positive or negative in the third quadrant? Negative. Right. So I know my answer is going to be negative, and the cosine of 60 is? There's your answer. -1/2. It's a matter of using reference angles to bounce yourself into the right quadrant to find the answer. Okay. Same deal, tangent -210. If you spin tangent -210, we're going the wrong direction. We're coming up. Are we passing 180? By how much? 30 degrees. So I'm coming up this way, which gives me a reference angle of 30 degrees. Tangent, second quadrant, will it be positive or negative? It's going to be negative, very good. So if I go back to my 30-degree angle, that I already have my triangle here, tangent was opposite over adjacent. 1 over root 3, well, we write it as root 3. Very good. So it'll be a negative root 3 over 3. Okay. And then lastly, 11 pi over 4. Does 4 go in, oh, how many times does 4 go into 11?
2.
Twice, how much left over?
3.
So there's 2 pi, and then you said there's what, 3/4 left?
Yeah.
Which brings us back to this second quadrant with a pi over 4. Very good. Pi over 4, 45-degree reference angle.
1.
So 1 root 2. Cosecant is the inverse of what trig function?
No. Wow.
Sine. Sine would be opposite over hypotenuse. Cosecant would be hypotenuse over opposite. So this one would be root 2. And is this value of sine positive or negative in the second quadrant? Good. I think that's enough to get you through the day 1 stuff. Let me make sure here. Yeah, that'll get you through all that. Actually got you going in most of the other stuff too, so. we'll do some more of this. I got a couple more examples to finish this out for tomorrow. Tomorrow won't take long to do much of this work, so go ahead and get going on the day one. We'll finish out the day two tomorrow, and then we start with figuring out angles, given what angle has this and stuff like that. It's exciting. Oh, Trig, you're so much fun. Ah.